Hi, this is our final project for CS598 Deep Learning for Healthcare, where we have reproduced a deep learning paper named A Critical Evaluation for Local Explanation for Assessing Cervical Cancer Risk Factors. This is me, Himanshu, Jeremy, and Mahesh in the team. Before I start with the presentation, let me go ahead and start the execution of the notebook. For the purpose of this demo, I'm going to skip the visualization and pre-processing and start right in the processing. I'll start the execution and go ahead with the explanation of the original paper. Cervical cancer is a life-threatening disease and is one of the most prevalent types of cancer affecting women worldwide. Being able to adequately identify and assess the risk factor that elevate the risk of cervical cancer is very important. The paper presents a critical analysis for several existing local interpretability methods for explaining the risk factor associated with cervical cancer. The ultimate goal of this paper is to help clinicians who use AI to better understand which type of explanations to use. The paper proposes a systematic approach for interpreting the predictions of a black box model using different interpretability methods. The approach consists of three main phases. The first, we train a series of models for cervical cancer risk assessment and choose the best one among these models. Next, we interpret the models from the previous step using a series of local explainability techniques. Then, we compute a series of matrices to assess the plausibility and coherency of these explainability methods considered. This is as described in this diagram here. Now we see that the notebook is still running. Let us wait for this to finish. Notebook has now finished running and we can see all the cells have been executed successfully. I'll quickly go over to the results where we have summarized the comparison between the original paper and our experiment. The original paper suggested that all sharp models primarily rely on one feature. We have also seen similar results in our experiment, while sharp being the most heavily dependent on one feature. The original paper suggests that Lime is as the most faithful model for explanation, but we see a slightly different results here. We see Lime performing well up to 40% of the feature, while accuracy of the dice model falls drastically till the removal of 30% features. The original paper mentions as RF as the best performing model, while we see that RF, LR and MLP produced the best result with a score of 1 on F1 accuracy and precision. Paper suggests that 3-sharp and sampling sharp are the most consistent pair, while local surrogate and dice are the least consistent pair. We see the same results, then K-sharp and sampling sharp having least score of 0.025 and local surrogate and dice has the least consistent pair with 1.14 score. The recent paper suggested that Lime and K-sharp and local surrogates found to be least stable with a lot of variability. We also see similar results in our experiment.